Everyone, I am K. Bhargavi Reddy. I am currently pursuing my BTech degree in Electrical and Electronics Engineering from Jawaharlal Nehru Technological University, Hyderabad. I am going to now present about what I have learned from this free online internship offered by Ematex. The project I have done is home automation, which is controlled by blynk app. The softwares I have used are Arduino, blynk, picsimlab, and virtual serial port tools. In Arduino, I have done the coding. In blynk app, I have used different switches and gauges to control the components. picsimlab is used to connect different components with Arduino, and virtual serial port tools is used to connect different serial ports. At the starting of this course, I have learned about C and embedded C, in which I've covered these following topics. After that, I've also learned about C++, introduction, difference between C and C++, its features, templates, and standard template libraries. After that, we started implementing the project. As a part of project implementation, I've done the following projects. The first one is LED dimming, CLCD, temperature system, which will be used as heater and cooler, LDR, which is used as garden lights system, serial tank. And then we've combined all of this project to make our final project, which is home automation using blynk. Here are the files which I've gathered at one place. So for the LED dimming, Arduino code is written like this. This is the code for the dimming of LEDs. I've compiled the sketch already and saved it as hex file. This is the LED. I'll load the hex file. And now you'll be seeing the LED glowing with 0 intensity till the complete intensity. So as you can see, after it reaches its final intensity, it will get turned off itself. This is about LED dimming. The next project is CLCD. This is the Arduino code for the CLCD. I've entered internship so that this will be displayed on the CLCD. I've already exported the compiled binary. So now I'll be showing the picsimlab. This is the CLCD. I'm loading the hex file which I've already saved. As you can see, internship is displayed on the CLCD. The next project is temperature. This is the code. This will also display the temperature in the LCD. This is the temperature system, and as you can see, initially nothing is displayed. The temperature will be displayed. The next one is LDR. LDR is nothing but light dependent resistor. It is a passive electronic component whose resistance changes with light intensity. A light dependent resistor is used in devices like automatic lighting and camera light meters. It is also known as photoresistor. So in darkness, its resistance is very high. When light shines on it, its resistance decreases. This is due to the semiconductor material it is made from releasing more electrons to conduct electricity when exposed to photons from light. It finds its applications in burglar alarms, automotive headlights, greenhouse automation, camera light meters, and automatic night lights. So this is the code for the LDR system. We have declared the pins. I am going to compile this sketch and export. Now I've completed the exporting of compiled binary. It will be saved in this file as HEX file. I'm opening the spare parts in the picsimlab. As you can see, there is an LDR sensor and an LED. As you can see, now I'll increase this and the LED glows. When I'm decreasing it, the LED is turned off. This is how an LDR sensor can be used for the garden light system. The next project is serial tank. This is just the serial tank without any CLCD display. This is the Arduino code for the serial tank. We have defined the inlet valve, enable, disable, and outlet valve. We have also given the delay time. So there will be a delay after enabling the inlet valve, and there will be a delay after enabling the outlet valve. Now I'll be opening the picsimlab. In this, I'm going to select serial remote tank. As you can see here, serial port which is connected to this serial remote tank is COM3. I'm going to change it to COM2 and I'm going to select file, configure, and here the serial port used is COM1. I'm using COM1 and COM2 because I've created a local bridge using the virtual serial port tools. So I've created it using this option, creating the local bridge. I've selected port 1, COM1 and COM2. So now I'll be connecting it to this Arduino board, and as the file is already loaded into this, the serial tank is filling. Here the volume is shown. I'll reload the hex file. Here you can see inlet valve is enabled. And once the tank is filled, the outlet valve is enabled. So the volume is decreasing now from the 3000 value to 0. In the code, we've given the maximum value of volume to be 3000 and the minimum value to be 0. So once the volume reached the minimum value, the outlet valve is also disabled. Now I'm going to show how I've used CLCD to display the value of the volume. This is the code for serial tank using CLCD2. So we've used the same code for the serial tank, but we are going to integrate it with the CLCD code. So LCD set cursor is set to 0, 1 and volume is going to be printed. We've also defined volume and these are the libraries which we've used. Now I'm going to show how it is going to work in the picsimlab. Once again, I'm going to select the port of serial remote tank to COM2 and we are going to check if it is connected to COM1. This is because I've used a local bridge between COM1 and COM2. In the spare parts, there is only one CLCD display. I'm going to connect it and now as the serial tank is filling, the volume is shown in the CLCD display. You can see the same value over here and here. So you can see the final volume is 3000. In this code, I have not used the disabling of inlet valve or enabling of outlet valve. So once it is filled, it is stopped. I am going to once again load the hex file because before I haven't.
So you can once again see the volume is increasing in the serial tank, and CLCD is displaying the amount. Now, using all of these basic project requirements, we are going to implement it to create a final project of home automation, which includes garden light systems, heating and cooling systems, which we are also going to use blynk app to control all of this. First, we've used blynk IoT on web browser. This is the interface. So here, this is named as one, in which I've used all the switches. As you can see, I've already created switches named as heater, inlet, cooler, outlet, and two gauges, which are temperature and water volume. I'm going to show how I've done this. So we have to go to developer zone, in which I have to select a template. We'll be creating a template of your wished name. Now you have to select data streams, in which you can add data streams. I've already added heater, temperature, cooler, water volume, inlet and outlet with pins V0, V1, V2, V3, V4 and V5. I'm going to add a new data stream named as V6 itself. So this is the pin which I'll be using. So I am going to use V6 itself. You can also choose units. This is the minimum value and maximum value. For the setting of water volume, I have set minimum as 0 and maximum as 3000. Similarly, for the temperature, I have set maximum value as 100, and then I have to create it. So there will be a new data stream. Now I'll be clicking save and apply. As you can see, a new data stream is added. Now I'll be clicking web dashboard, in which we have different types of components. I'll be dragging the switch button. I'll be clicking the settings, and as you can see, you can change the title. I can either create a new data stream itself, or since I've already created a data stream which is V6, I'll be choosing that. We can change the color of the icon and then save and apply. Now you can see I have a new switch called V6. In this way, I have created all the switches and the gauges. We can also see that the device is offline right now. Once I'll be connecting, it will show online. For the final project, this is the Arduino code. So as you can see, there are various files in CPP H formats. So we've used all these libraries. This is the complete code. We've defined all these values, and these are the codes for serial tank, and this is for the temperature system. This is for the LDR. So these first three lines are copied and pasted from the blynk app. So now we are going to again use the blynk app. As you can see in the devices, I've selected this one, and here there is developer tools. Once I scroll down, here we can see firmware configuration. So I'll click this. So code is copied to clipboard. Now I'm going to paste this over here. Now I'll verify it. The code is done compiling, and I'll be exporting the compiled binary. Once this is done, I'm going to open the picsimlab. I've already saved the workspace, and these all are the spare parts. This is the CLCD, this is the LED and LDR sensor, and this is the temperature system. I'll load the hex file. So now I'll be opening the serial remote tank. Now I'll be opening the blynk application. As you can see, the device is now online. So the first switch is heater. The second one is cooler, inlet and outlet. The inlet valve is turned on. The volume will be displayed here as well as here. Now I'm going to turn off the inlet valve and turn on the outlet valve. The water volume is decreasing. It will be displayed here. Next I'm going to try out the heater and the cooler. As you can see, the temperature system is working. The temperature is increasing. It is showing here as well. So as you can see, as I'm increasing this, the LED is glowing, and when I'm decreasing this, the LED will start to turn off. This is used as garden light systems. Now I'm going to show how I'm going to control the Blink app in my phone.
So now I'm going to open the Blynk IoT app on my phone. As you can see, there are no widgets which I've added. So now I'm going to add them. So as you can see, I've added all the 4 switches and the 2 gauges: heater, cooler, inlet, outlet, temperature and water volume in my Blynk IoT app. As you can see, there is a green icon here which shows that my device is online. Now I am going to turn on the inlet valve to see if cereal tank is going to fill. So as you can see, as I've turned on the inlet switch, the volume is also increasing. Over here also it is displaying as well as in the LCD. Now I'm going to turn off the inlet switch. You can see the inlet valve is disabled and the volume is constant at 1710. Now I'm going to turn on the outlet valve. As you can see, the outlet valve is enabled and the volume is decreasing in the LCD display as well as in my Blynk app. Now I'm going to turn off the outlet valve. Now I'm going to turn on the heater and the cooler too. As you can see, the temperature system is working. I'm going to turn off the cooler and turn on the heater. As you can see, the fan has stopped turning and the temperature is gradually increasing. You can also see it on my screen. So you can see the temperature is gradually increasing. Now I'm going to turn off the heater. And you can see that as I'm increasing this, the garden light system is also working. The LED is turned on. As I'm decreasing this, the LED is turned off. So this way we can integrate Blynk app using Arduino code. We can complete this project of home automation. So by this presentation, I can conclude that I've learned C, C++, embedded C, and also the usage of Blynk app, picsimlab, and Arduino. From this internship, I've learned the following things, and I've completed my project of home automation using the Blynk app. Thank you.